because today we're going to be doing a lot of Excel. So I think I've got some duplicate slides here because I know that we talked a little bit about different types of distributions right at the end of last class on Wednesday. What we hadn't really done is kind of how we build these histogram tables in Excel. So there's a bunch of slides, some of this is we're going to be trying to recreate this in Excel today, right? So I'm really going to walk you through step by step. We did a little bit of how we graph kind of time series data or scatter plots in Excel, but today we're going to focus on introducing some built-in functions that Excel has and some things that I want you to kind of learn as we're moving forward in the course. So we go to Canvas, and actually something's wrong. I have to do that. So here we go. Files, in-class data. I put up this enrollments blank file. So that graphing data week 1, that was what we were kind of using last class or last week. And I put up the saved version of everything that I had done. All right, so it'll kind of have the original blank file, then kind of all the tables and graphs that we created. Now, obviously, it's not like detailed instructions in that file of how we did that. I had to be here or go back and watch the video. But I'll do a similar thing with this enrollments file. So today, we'll start working with it. It will be blank, right? As we kind of work through things in class, at the end of class, I'll save it and post the completed version of what we did in class. So you can always kind of go back and have that reference file, okay? Any questions before we jump into this here in the meeting? So especially after today, even some of the stuff that we're talking about in Excel should help you with that first Connect homework, which I believe the due date is set to be at the end of next week. So the end of next Friday, September 9th. Let's see if I'm remembering this correctly. Yeah, there we go, September 9th, okay? So we'll pull open this enrollment blank file, and I've got kind of 2 worksheets. So we're gonna focus on this Indiana one. If we go over to the data, I've got a bunch of different universities from Indiana, and I have what their enrollment was, and I think this was 2019. Now, obviously, you can see Ivy Tech is like every Ivy Tech location, so they're going to easily have the highest, but it goes all the way down to, I don't know, Trine University, right? Kind of pretty small. So we talked about, I think at the end of last class, if not, we said discrete data, as long as it's a small number of responses we could see, so like the number of siblings you have, creating a bar graph or a frequency distribution graph is just the same as when we're dealing with qualitative variables, kind of like the heart disease, the cause of death, right? When we have continuous data, it's a problem, right? Because income data, I can't count the frequency for everyone who makes $0, 1 cent, 2 cents, 3 cents, all the way up into the millions. It's going to be a ridiculously long graph. So we have to force it into these bins. We talked about kind of calculating the optimal bin length. Is this ringing a bell at all, Tony? Yeah, a little bit, okay? So we're basically going to do that in Excel today. So I said the equation that we had to determine the optimal bin length was taking the maximum value, subtracting the minimum value, and then dividing by the number of bins that we wanted. Well, here I'm telling you, we want 6 bins, right? I'm making it easy. You don't even have to choose this. I'm going to give you that when it comes to an Excel homework or on those Connect homework problems. So we've got 6 bins. I want to find the minimum and maximum value. So I'll show you a couple things in Excel that make life a little bit easier. So if I go to this very first cell and I hold Control and Shift, so I hold those down, or if I'm on a Mac, anytime I say Control, Command, right? So hold Command and Shift, hit the over arrow, and then hit the down arrow. It selects my entire data set for me, right? It went to the very last observation, and it went over to the very last variable. I then go up here to data. There's a filter option. I already have it turned on. If it's turned off, it just kind of looks like this. I turn that on. Notice there's these little arrows that pop up for every single variable. Well, one nice kind of feature of this filter tool is it allows me to click on that little arrow. I can see every single possible response that I have recorded for this variable of enrollment. I also can do things like sort it, right? So I could sort it from smallest to largest and very quickly see what university has the lowest enrollment, right? So I could also go largest to smallest, very quickly see what has the largest enrollment, okay? So that filter tool will be kind of helpful. There's a couple questions in the Connect where it, I think it gives you some data, and kind of using the filter, it allows you to kind of calculate means or averages for different groups. We haven't talked about calculating means or averages yet, but that's why kind of that due date's down the road, because we'll kind of chip away at those types of topics here this week. okay? So I just wanted to kind of show that to you as we get going here. Well, instead of just eyeballing the data, like here, I didn't have a ton of universities from Indiana, but what if I had like all the universities? So if I go over here, I don't even know, there's like almost 2,500 observations. I don't want to have to sort this and like look through to find the minimum and maximum. So what's a nice, easy shortcut I can do? So Excel has these built-in functions, right? So I kind of showed you last class, if you put an equal sign, you can use cell references, you could use kind of do basic math, but you can also use some built-in functions that Excel has. So the first one we're going to use is the minimum function. So it's equal sign min, and then you start the parenthesis. You basically then just select the numbers you want to find the minimum of, okay? So equals min, I'm going to select this entire column of data, and it's going to find the lowest value. And I can scroll up and show you that once I select it, it puts that cell reference in there for me. So C2 through C51. And when I said through, that's that colon, right? It means start in C2, go to cell C51. Now I can close the parenthesis here and hit enter, or by default, if I hit enter, it'll just automatically do it for me, right? And here, sure enough, it returns to me that minimum value, okay? Any questions on that before we keep moving? So if equals min finds me the minimum, what do you think finds me the maximum? Equals, yeah, that one's not too bad, right? So I go here. Now I could select it with my mouse, or I could use that shortcut. Just click on that first cell, hold Control and Shift, or Command Shift on a Mac, hit the down arrow. Now notice I can't see where the original cell is, but there's a formula bar up here that tells me, oh, it put that cell reference of C2 through C51 there. Now I could scroll all the way back up just to make sure, or when I'm down here, if I just hit enter, it closes that parenthesis and sends me right back up to where that cell was, okay? Now that doesn't seem like it saved me much time, but if I was doing something like, so I'll do that minimum function, if I was using all these universities, you know, scroll back up is going to be a lot more of a pain. If I just hit enter and it automatically closes that parenthesis for me, that's a lot more useful, okay? So I've now got my maximum value and my minimum value from this data, right, or from this variable. So to find the optimal bin length, we said I'm going to take that maximum value. Now, instead of typing it in, I'm just clicking on the number and it puts that cell reference in there for me and will grab that value from that cell. So instead of typing everything out, taking a bunch of time, just click on the numbers that you want, right? So I want to take the maximum, subtract the minimum, and I have something goofy on my laptop I need to change, and I keep forgetting to. So I can't select this cell that the bins is in because it makes this box larger, but I know that cell that the number of bins is in is what? G3. So I could either click on that cell or just type it in. Now, what's going to be a problem if I'm trying to calculate my optimal bin length using that formula, where I take the difference between the maximum and the minimum, and I divide by the number of bins? Why is this going to give me a goofy number? Not necessarily because of my out. Yeah, so when we're doing math in Excel, we have to be very careful still of the order of operations. So here, it's going to divide the minimum value by my number of bins and then subtract that from the maximum value. That's not what we want, right? If we go back to that formula we had last week, it was the maximum minus the minimum in the numerator. So if you're ever not sure, err on the side of caution and use parentheses, right? Make sure it takes that difference first and then divides it by the number of bins, okay? Now a bin length of about 12,000, that looks a little bit more appropriate, okay? Any questions there before we keep moving? Okay with that? Yeah. So ultimately what we want to do is now create these 6 bins, and we count the number of observations that have an enrollment value in between 279 and about 12,347. Right? And then the number of observations that fall in this range, and then the number, and then once we have those frequencies, it's just inserting that column or bar chart, right? That gives us that nice kind of histogram. So it's just like when we were doing it with the heart disease data, It's just now we have a little bit more work to do to find our frequencies. It didn't just download in the data for us, right? Because we're taking the original data and forcing it into these bins, okay? So I'm gonna set this up in a way, so hopefully by the time we get done today, you'll see it may not make sense originally why I'm doing it, but at the very end, you'll see how it saved me a lot of time. So I need to find where each bin starts and stops, okay? So it's very specific in my equalities here. So this first one is gonna be, it starts at 279, and the cutoff for this first bin and the second bin is going to be that value of 12,347.33. Now, I typed these labels out ahead of time so that we have some nice labels typed out for our graph and we didn't have to waste a bunch of time. But how could I figure out where that first bin is going to stop? Well, if the minimum value in my data says 279 and the optimal bin width or bin length is 12,068, well, then this minimum value, right? I guess I could, instead of typing 279, say, start at the minimum value, hit enter, and then this bin will stop. Well, if it starts at 279, it's going to stop at 279 plus whatever that bin length that I want is. And we had that calculated up here in this cell G4 last year. So once again, I know that I want to start wherever this bin's starting, in this case, the minimum value. And then I want to stop by adding whatever that optimal bin length is to that starting value, okay? Any questions on why I'm doing that? Right, so giving some easier numbers. Let's say the lowest value we had was 0, and the bin length that we had was 5,000. Well, then the bin would start at 0 and stop at 5,000, right? I'm just adding that bin length to that lowest value. Just here, it's not 0, so it's going to be a little bit different. Now, where does each bin start at after that first one? Well, it's going to be wherever the previous bin left off, right? This is where we said we have to be careful. If I'm counting incomes, I said I have to go 0 up to, but not equal to 50,000, and then start the next bin at equal to or greater than or equal to 50,000. Right, so we got to be careful of those equalities. Well, I was when I type these labels out. Notice the equality is always on the lowest value, but not on these higher values. So what I'm going to do is say, okay, look, I know the next bin will start where the last bin left off. So I'm just going to click on that value. Is that clear why I can do it? All right, it's that cutoff, right? Even though the equality only goes on one of the bins, that cutoff value where the last bin stopped, well, that's going to be where the next one picks up. Okay. And then where does this bin stop? How did I come up with that 24,415? Well, I just took, where does this bin start? Add to that the length of my bin that I want, right? And I'm going to continue to do this all the way down. Well, why am I going to type this out a million different times? Maybe I can exploit the fact that when I copy cell references, they update. So think about it this way. This bin started where the last one left off, H7, right? Where is this bin going to start? Where the last one left off. So I could click on this and it would put in that H8. Or if I look up here, what happens if I copy this down one? Remember, when I copy cell references down, if I go down 2 rows, it updates at 2 rows. So if I copy this down 1 row, H7 will become H8, which is exactly what I wanted, right? I always want to go back to the previous bin where it left off. And then what do I want here? Well, it's going to be, where did this bin start plus whatever the bin length was. Now, instead of typing this in again, if I look here, if I copy this down one, G8, oh, it's going to update to G9. Okay, so it's going to start off at the new bin's starting location. But then I always want to add what's in G4. So I can't remember. I have another section that is working at a different pace than you guys. So did I show you how to freeze cells? I thought I did. The dollar signs. Yeah, so if I copy this down, I want G8 to become G9, right? Start where the new bin starts at. But I always want to keep adding that same cell reference of G4. So I'm going to freeze it Now I could just type the dollar signs in front here, or do we remember what the shortcut was? F4 if you've got a PC, or Command T if you have a Mac. All right. So I hit that F4, get my dollar signs in there. Now when I copy this down, this cell reference won't change. So I'll copy this row down, copy this, sorry, this column down. And now notice I'm getting the values that line up with those labels I had created before class. Right? And it saves me a lot of time. I really only had to enter this in. I actually entered more in than I had to, just to kind of show you step by step. But I really only had to get that second bin and then copy down. Didn't matter if I had 6 bins, didn't matter if I had 20 bins, right? I only have to enter it in there that one time. It saves me a lot of time to kind of exploit the fact that when I copy those cell references, it'll automatically update to kind of use the values for the next bin. Okay? Any questions up to this point? Okay with this so far? Correct. So it's going to look a little bit trickier because I'm going to show you a built-in function in Excel that requires a little bit more work. Okay. So we've got this built-in function, which is the COUNTIFs function. Now, up to this point, I've showed you the min, the max function, how you do math. All of those only took like one, what we call arguments, right? Like, if you think about like arguments of a function, right? So it's like y is equal to mx plus b, right? You tell me what x is, and if I knew the constants, I could tell you what y is, right? So x is the argument for the function of y. Well, here, these built-in functions, sometimes they'll take one thing, but sometimes there'll be like variables z in there, or variables q, x, whatever, right? So we're going to have to tell it multiple things. So the COUNTIFs formula works as follows. How are we going to come up with this frequency? If we were doing this by hand, we would go through the data and count the number of observations that met what 2 criteria. Well, if they were greater than or equal to 279, but also less than 12,347.33, we would count up the number of observations that met that criteria. That's the frequency for our first bin. I don't want to do this by hand, especially if I had that huge all university data set where I've got 2,400 observations. So I'm going to use this COUNTIFs formula to do it for me. So the first thing I have to tell it is the range of the data. So a nice, easy way, quick way to do that is go over here, select the first cell, Command Shift on the Mac, hit the down arrow. I'm going to scroll up so that we can actually see. Sure enough, it put in that cell reference there for me. Okay. C2 through C51. I'll then put a comma, and it says, okay, look through that data, and does it meet this first criteria? Well, what's my first criteria? Is it greater than or equal to 279? But because I have this minimum and maximum of each bin column set up, I'm going to say, okay, is it greater than or equal to? And when you type it just like you'd say it, right? If it's just a greater than sign, you put just a greater than sign. If it's greater than or equal to, greater than, then an equal to sign. But you have to put those equality operators in quotation marks for Excel to know, okay, these are like, I should be taking these as the equality arguments, right? It kind of allows it to identify that. Right? So is it greater than or equal to, and I could type in 279, but if things change, right? And we'll see that if I don't just use the number, I can actually only have to enter in this COUNTIFs function one time and then just copy it down for the rest of my bins. So instead of typing in 279, we're going to put an and sign. And then this lets Excel know, okay, use a value as my kind of criteria that's in this cell. So is it greater than or equal to 279? Okay. Any questions there? And the quotation marks and the and sign, that's just the syntax of Excel. And that's just the arguments that it needs to say, okay, look, here's the equality operator I want you to use. Here's the cell that has the value I want you to use. Okay. Comma. So we check the first criteria. Now we need to go back through the data and see, is it also less than 12,347.33? So it's kind of annoying. It seems dumb, but we have more uses for the COUNTIFs formula coming down the road. So for now, it seems dumb, but we'll be able to, different types of problems, the COUNTIFs formula here, it will look different. But for the histogram, right, building this column or this bar chart of these frequencies, we're going to have to select the data again. So I could go back over, click, use the shortcut, Control Shift, Command Shift, hit the down arrow, or I can see what it is right here. My range of data is in C2 colon through, whoops, C51. So a lot of the time, especially with bigger data sets, instead of going over, selecting the column, scrolling back up so I can see what I'm doing, if I've got it in front of me, I just type it out again, right? I mean, it saves me, especially on a laptop. I hate scrolling around on a laptop, right? So I just type that in again because I can see it's right there. The second criteria was, is it less than, put that in quotation marks, right? The max, oh, what did I forget before I started clicking on things? My and sign, right? So is it less than, put an and sign in there, that maximum value of the bin, okay? So what this should do is go through the data, right? Almost like it tells you. Go through the data, count it if it's greater than or equal to 279. Then go through the data again, and then of the remaining observations, only count them if they're also less than that 12,347. Okay? So if I hit enter here, it should give me the frequency or the number of observations that are in that range. Sure enough, 43 of those universities are, right? And that kind of makes sense. If I'm looking over at the data, I really only had a few that had really high enrollments. Most of them, right, going down to the 8th observation, everything below this is below that $12,000 or $12,000 student enrollment cutoff. Right? Now, I told you I was setting it up this way to save myself a lot of time, right? I could have typed in this calculus formula and used all these cutoffs every single time. But notice, if I were to go down to the next bin, what would I want? Well, I'd want to type out that calculus formula and say, go through the data, just like I did up here. But now I only want to count it if it's greater than or equal to this 12,347. Well, here I had greater than or equal to, that's what I wanted. But instead of G7, when I go down to the next bin, I would want to say, is it greater than or equal to what in cell G8? When I copy that down, what happens? G7 becomes G8. And I only want to count it if it's less than, not H7 now. When I go down to the next bin, is it less than H8? So if I copy this down, these two cell references will change the way I want them to. But what will also change? Cell references for these data. So if I don't freeze any cells here, I just got excited. I'm like, sweet, save myself a lot of time. Notice by the time I get down here, oh yeah, it's using the right cutoffs, but look at the range of data. Oh, I'm missing the first 4 or 5 observations there, right? So when I copy that first count ifs formula down, I want the cutoffs for each bin to change, right? Each bin has a new minimum and maximum, but that range of data should not change at all. So we're going to select it, hit F4 or Command T on a Mac for both of those places where I reference the range of data. Now, when I copy this down, the range of data shouldn't change, but the minimum maximum of each bin should then update how I wanted them to. Okay. So I'm going to copy this down now. Once again, when I get that thick black plus sign, just left click, drag it down to copy. I still have some zeros here, which I'll show you kind of why this is in just a second. But one thing I need to be careful of, notice how all my bins, there was no equality on the maximum value until, to make sure it's exhaustive, when I get to the last bin, I need to make sure I include the highest possible value or the maximum value, so there was an equality here. When I give you that first Excel homework, my labels will have the equalities just like how I want you to do them. And it could be something very similar to this, okay? So once I get down here, the only thing I needed to change was to make sure, oh yeah, for this last bin, I need an equality. If I can get this out of the way so you can see this all in one line. There we go. I need an equality on the maximum of that bin as well, right? Just to make sure that I've kind of matched up with the labels there. Okay. Any questions over anything? Want to see a cell again, or why I did something the way I did here, or kind of go back? We're okay with this. Once again, when you're including those equalities like greater than or equal to or less than or equal to, you type it out like you say it. The greater than or the less than sign comes first, and then the equality comes second.
So a comma, we always have to put a comma for it, right?
Say that again.
Because I remember you saying like sometimes it can just be something as small as a comma.
Yeah, so right here, this count is formula, and it kind of lets me know down here. I mean, it's small, so it's hard. I can't zoom in. That just doesn't change the font size for some reason. Tell you the range of data, first criteria, then the range of data again, second criteria. Actually, if you really wanted to here, you could go out with as many criteria as you wanted, right? You could use multiple variables. You can use some crazy stuff. For us, this first assignment, basically this count ifs formula just needs these 4 things, and each one needs to be separated by a comma. So tell it the range of data, comma, what's the first criteria, comma, what range of data do I go back through again, comma, what's the second criteria. If I forgot a comma, notice Excel gets really mad at me. And it's like, we don't have enough arguments or whatever the error message says. And you're like, well, what am I doing wrong? Sometimes it's as easy as I thought I hit a comma and I didn't. Yep. Or, well, yeah, it's not very helpful in how to fix it usually, but if I forgot, if I got something here, it kind of helps me, but not really. It's just basically going to let me know I made a mistake somewhere. Oh, sure enough, I forgot to close that or, have both quotation marks. Oh, what did I do here? Did I hit delete on something else? No, it should be good now. Oh, do I want? Yeah, I'm good. Wait, what did I do wrong here? I was changing things and now I'm not sure. So C2 greater than or equal to that. Oh, I put a bunch over here on accident. Sorry. There we go. Now it's working again. All right. Okay. Any other questions before we keep moving here? So I'm going to go work through this next one a little bit quicker because it's really the exact same thing we just did. I'm just going to change some of the values a little bit. All right. We're going to see if we can kind of walk through it here. So I've got these values over here. I wasn't as nice with the labels here. I should have really kind of said, greater than or equal to, should have typed something out like this, right? So that you could really tell what's going on with the equalities from the labels, kind of like you could over here. I just got a little bit lazy because I just wanted to add in some additional stuff to show you some things that you might have to kind of tackle in that first Excel assignment. So the labels don't look as pretty, but you can kind of imagine I'm using a very similar method here where each bin starts where the next bin left off, and I have to make sure I only put the equality on one of those. Okay. So here, I'm going to start my first bin at 0, and I'm going to stop at 7,500, right? So instead of typing this out, I'm going to go up here, and this new bin length, I don't want to use that optimal bin length that came from that formula. That was a good starting point, but the problem is, and I forgot to show you this once we were done, if I want to graph these frequencies, it's going to be as simple as I select these labels, hold Control or Command on a Mac, select my frequencies. I can get this out of the way. There we go. Go to Insert, this column or bar chart. Now I've got my frequency distribution, right? Well, these decimals and these numbers, these are really weird cutoffs. They're not very good to look at. I might want to choose something that's like, it makes a little more, rounded to the hundreds or something like that, okay? But that's as simple as it is. Once I get those frequencies, just insert the bar or column chart, okay? That's what I want you to do for that first assignment. Now I'm going to delete this just to free up my screen here. But instead of these odd cutoffs, I'm going to use the bin length of 7,500 so it looks a little bit cleaner once I create the graph. Well, each bin is going to start somewhere, and then it's going to end whatever that bin length I wanted was. So 0 plus that bin length I wanted of 7,500. And then the next bin starts where the last bin left off, right? So just select that maximum of the previous bin. And the maximum of the second bin will be, well, where does this bin start plus whatever that bin length is, okay? Now, this is where if I copied these down, I might think, oh, I only have to do them one time, or at least that's what Professor Landis said. Well, what the hell is going on, right? And the reason why is because, yeah, every time I copy this down, the minimum of the next bin instead of M7 should be M8. Okay, that looks like it should be working. But remember, when I copied this one down, I should always be starting at the minimum of the bin, adding that bin length. But when I copy this down, now it's adding a blank value, right? So I need to make sure I did what? Go back up here and make sure that, well, actually, I should show you right here. Right? I freeze that cell reference, right? So I'm always going to L3 and grabbing that bin length of 7,500. Okay. But I want L8 to update, right? Because the next bin, I want to start at L9 and add to it that 7,500, and then so on and so forth. Any questions why I'm doing that? You sure? Afraid to ask? Okay. So now, when I copy these down, okay, now everything looks like it's working out pretty good. Okay. So this just has cleaner values, right? I mean, I didn't spend time making the labels prettier, but the labels will look a little bit cleaner when I do it this way. And I could have even done, 7.5K, right? I could have abbreviated with my labels so that, they don't take as much room there. And everything's looks good. With one exception, I wanted to show you another example where if we don't use the optimal bin length, we might need to create these catch-all categories. Okay? So 37,500 or greater. You can use, there is just a count if formula, which is basically look through the data, one criteria, right? Is it greater than or equal to 37,500? Or, so I don't have to type in another formula, I can keep using this count if formula. It's just that being greater than or equal to 37,500, I can't put the maximum at 45,000. The maximum in theory really should be infinity. There's no way to enter infinity here into Excel. So what do? I put a 1, just hold the 0 key for a while, right? I'm just going to put a huge value in there, and it's basically infinity, right? No school is going to have 1 with 38 zeros enrollment. I don't even know what number that would be, right? So that's a good way to kind of just save yourself a little bit of time. You don't have to type in the count if formula. You can just keep using that count ifs, okay? And I won't expect you to use that count if formula. You can kind of set it up this way. Now, this also brings up a good point, which is this E plus 38. Why am I getting letters when I just typed a number in? It's basically once your value gets too large, Excel will sometimes automatically update the format. It can't show you, there's not enough space for 38 zeros or whatever I had in here. So it's telling you take the value of 1, and this E plus 38 means move the decimal point 38 places to the right. So 38 places to the right would mean 38 zeros, right? We'll start dealing with probabilities where we might get really low values. Sometimes it'll be like E to the negative 38, which means take the decimal and move it 38 places to the left, right? So 0.37 zeros and then a 1. Okay? But this is a nice little trick for us. We can kind of basically use it as infinity. Okay. Any questions on this before we keep moving? Okay. So I've got my minimum maximum of each bin. I'm now going to type out that count if formula again. Once again, I'll go through it pretty quickly. I'm not going to go over and select the data, although I could. From my memory, at least, I remember it's from C2 to C51, right? We're using that same data. We've just changed our bin lengths. So I want to count it if what is true. Well, is it greater than or equal to? But that has to be in quotation marks. Throw in an and sign. Greater than or equal to the minimum value of that bin. Comma, go back through that range of data. All right. And check if what second criteria is true. Is it less than and sign, right? We have to use that and sign after the equality operator, the maximum value of the bin. This is exactly the same thing that we had before. It's just we're now in different columns because we're a little bit further over in the worksheet. Okay. Now, what did I say before? What is the problem if I just try copying this down? It'll update the minimum and maximum of my bins correctly, right? L7 and M7 become L8 and M8. But what do I need to do? Yeah. Hopefully that was a really annoying, boring question, right? If you're paying attention, right? So I just highlight that range of the data, hit F4 or Command T, and it freezes those cell references, throws those dollar signs in there for me. Now I hit enter to get out of the cell. I drag this down. And the reason why I did this also is if I use that optimal bin length formula, all of my data is in this really low bin. And I've got some zero. Well, that's not very interesting. It doesn't tell me a whole lot about the distribution of the data. Whereas if I maybe create some smaller bins, not as wide, and then create a catch-all category, I get a few more, a little bit more delineation of the data there. But even this isn't great, right? I might even say, well, I want to see like more, I want to create even smaller bins. So instead of 7,500, what about 3,500? Well, if I've used cell references and I've set everything up this way, when I hit enter here, everything should automatically update and I should get my new frequencies for these new bins. Now my labels won't match up, right? Because there's no cell references I can really use there. But in terms of where my bins are going to start and stop, which would then allow me to create my labels, like type them out, and I'll get my new frequencies for those new bin values. So if I hit enter here, notice it updates everything here. Now, instead of 37,500 or greater, my last bin is going to be 17,500 or greater. And now you kind of notice I'm getting a few less universities in that low bin, and they're kind of seeing a little bit more of how they're spread out across these other ranges of values. Okay. Now I'm going to change it back. I was just showing you that the nice thing about cell references is if we do end up changing values, it'll automatically update things for us. Okay. So down here, I have a total here. If I take these frequencies and I add them all up, what should I get? Well, every observation in the original data set should have been counted one time, at least in one of these bins. So when I add up the frequencies, they should just add up to the total number of observations, right? Because every observation was counted one and only one time. When I add up those frequencies, I should be counting every single observation. So a nice little built-in formula we can do to add numbers up real quick. So instead of going this number plus this number, right, I don't want to have to type all that out, especially if I had like 20 bins as opposed to 6. There's this built-in sum function. So the sum function, right, adding up, summing up values, you just start your parenthesis, you select the values you want to add up. Oh, this is in the way now. There we go. So I just selected those cells that had the frequencies I wanted to add up. Okay. Now, if I hit enter, I end up with the total number of observations, or the total number of universities I had over here was 50, which sure enough, my cells started in row 2. They went to 51. So there are 50 observations, right? So I didn't make a mistake, right? One nice check, and I didn't do it over here. I would kind of do the same thing over here, right? I could use that sum function, hopefully using that optimal bin length formula. When I add these up, hopefully I get 50 as well, right? Otherwise I messed up. Okay, I got 50. Well, and a really nice check to make sure, like, how do I know that there are 50? I could scroll over and look at the rows, but we can always find the number of observations using another built-in formula in Excel. And this one we'll use like to the end of the course. It's just that count function. So equals count, and then you select the variable that you're interested in. It basically counts the number of cells that have a value in it. So if I just select my data, starting from the first observation, using that shortcut of Control Shift or Command Shift, hitting the down arrow, notice it puts that cell reference in that count function for me. There we go. Oh. It's going to just count the number of cells that have a value in them, or basically count the number of observations. So hopefully, if I've done everything correct, this count function should give me the same thing as when I added up those frequencies. Sure enough, it does here. Okay. If for some reason, what's something I could do here? Oh, let's say, I don't know. What could I have done that would have screwed with this? Let's say I accidentally forgot to make this a really large number, and I just had this, so I was missing that maximum observation. Notice, oh, okay, now the sum of my frequencies doesn't match up with that count function. So that count function is like the gold standard. It'll tell you how many observations there are. If you add up your frequencies, it should tell you the total number of observations, unless you made a mistake. So using that count function to make sure that you have done everything correctly is just kind of a nice, easy check there. Sure enough, oh yeah, I was supposed to change this to just an absurdly large value. Right now I've got it matching up. Okay. Any questions on anything up to this point? So this is about as far as I'm going to push you for that first homework assignment, that first Excel assignment, which I don't know if I'll get it up there this evening. I gotta actually hit the road after this class, so I won't be able to do it right away. But for sure, it'll pop up on Canvas tomorrow. Okay. So once you have these frequencies, I would select my labels, hold Control or Command on the Mac, select my frequencies, then just go put in this bar chart. And I don't care for the home, you don't have to mess around with the titles. I just want to see you can get those frequencies. Once you get those frequencies, you can put them into a bar graph. Okay. What I don't want you to do, and it doesn't matter that I'm saying this, someone will do it, because by the time they procrastinate and forget and they go Google it, this is what Google will tell you to do. All right. So what I don't want you to do on that first homework assignment is simply select the data. This is a nice, quick, easy way to get a good rough estimate of what your kind of frequency distribution looks like. But when you are given certain parameters, when you're given certain bin lengths, when you're given equalities that might look a little bit different, when you have catch-all categories, it's a lot harder to use this built-in tool. And honestly, I've had like one student in the last, I don't know, 7 years that I've been teaching the stats course, who they have used it, they used it right. So your odds of using it right are very low. So I would tell you, do not use this method, which is to select the data, go to insert, and then there's this what looks like a bar graph, but it's called a statistics chart. If I click on that, oh, there's a histogram right there. That's all I have to do. Well, if I'm giving you an Excel homework assignment and it's worth like 25 points, I'm doubting that's all you're going to have to do, right? I want to see those count ifs formulas, and I want to see you kind of build the minimum maximum, because all those principles, and actually really that built-in count ifs formula, we're going to keep using that down the road. So I want to make sure that you know how to use it in what might not seem like a simple context, but it becomes even more complicated to use it down the road. So I want to make sure we can use it here first. So if I do select this, notice it creates these weird cutoffs. I can play around and change them and create catch up, but it's a lot harder to do. It's very hard to get to match up perfectly with like labels that were already given to you. And it doesn't allow me to update things. It doesn't allow me to change my bin lengths one time and have everything update right away, right? So I guess it's a useful tool to get a quick glimpse at it, but a more well-done histogram would be kind of how we did it over somewhere over here, right? And you're able to like see the frequencies and have the actual data to where you could copy and paste the tables somewhere as well. If I just use that built-in tool, I can't get those frequency values, right? I can see them on the graph, but I don't have them like physically where I could put them in a slideshow. Excuse me. Is that clear? Any questions on that? So do not use what I just showed you, right? I mean, immediately just showed you. I want you to use the method where you use that count as formula, okay? So what if instead I wanted relative frequencies? What's the only thing I should have to do to my frequencies here? Do we remember how we got, going back to like the cause of death data, frequencies to relative frequencies, all we did was divide by total number of observations. So I got the frequency here. I'm just going to select that cell, right? Don't have to type in the value, divided by my total number of observations. Now I can save myself a lot of time, because if I just copy this down for the next bin, I want to use its frequency. So N7 becomes N8, so that'd be good. But if I copy this down, why am I getting errors? I'm taking the frequency and now I'm dividing it by, oh, that total number of observations cell shouldn't be changing, right? So, okay, I should have froze that cell reference. So I go back up here. I want my frequency to update as I copy it down, but I don't want that total number of observations to. So I'll freeze that cell reference. Now when I copy it down, it always divides by that 50 or whatever value is in my total total cell. Okay. So now when I copy this down, hopefully this looks a little bit more appropriate, right? Our relative frequency is represented proportions, right? So if I add my relative frequencies up, what should those add up to? Do we remember? If I've done everything correctly, 1, right? Because my numerators are my frequencies, those should add up to my total number of observations. Dividing everything by the total number of observations, anything divided by itself is 1. This should be boring and redundant, and a reminder of what we've already done. How do I create my percent relative frequencies? Yeah.
You do the same thing we just did and multiply it by 100.
Yep. I take my relative frequency and I just move the decimal 2 places or multiply it by 100, right? Copy that down. What should this add up to? Just to kind of show you. Those should add up to 100%, right, of all the observations. Okay. Everybody okay with everything up to that point? I'm going to try to give you a little bit of an insight as to what cumulative frequencies are. I think maybe having a visual. So, this is the frequencies, cumulative frequencies, and if you guys can, so verse 700. I'm going to be a little bit lazy with my labels here, but they kind of should match up with what we have in the Excel assignment. If I'm graphing my frequencies, that very first bin should have a frequency what? Of 38. Right? So I draw my bar up here at 38. Okay. And if I want to do my second one, obviously I should write the equalities out better. But the second one has what? A frequency of 5. This is not drawn to scale, but right, it's going to be a lower bar. And then we kind of can continue. I'll just do the first 3 to kind of show you this. So 1500 and what? 22,500. If I remember right, this frequency is 3. Yeah. All right. So I'm just graphing this out by hand to kind of show you what it would look like. The idea of a cumulative frequency, right, is like GPAs. If I want your GPA this semester, you do what? You average out your letter grades across whatever courses you had this semester. If I want your cumulative GPA, you do what? You look for classes this semester all the way back to whenever you start, right? So the idea of cumulative is go back to the beginning. Okay? So a cumulative frequency is, well, what are the number of observations in the bin that I'm looking at plus every bin below it? Okay? So for the very first bin, it's almost like a trick question. What would the cumulative frequency be for the first bin? It's the frequency of the bin we're looking at plus every bin below it. There are no bins below it. So the cumulative frequency is exactly the same as its frequency, right? That first bin, nothing changes. So if we're looking at Excel, we would say, okay, the cumulative frequency here would just be what? Yeah, just select that N7 cell that had that original frequency there. Now for the second bin, the cumulative frequency will be the frequency of this bin plus every bin below it. So it should be that 5 plus the 38. Or if you're looking at the graph here, the cumulative frequency of this second bin should be the frequency of that bin, 5, plus every bin below it, 5 plus 38, 43. And then what about the third bin? That'll be the frequency of the third bin, which was 3, plus every bin below it. So 3 plus 5 plus 38, right? So there, you got a cumulative frequency of 46. Okay. Any questions over that idea before we keep going? So what has to be true about the cumulative frequency as I move to higher and higher bins? It can never go down. At the very least, I'd have a frequency where I've got a 0 and then it stays the same. But I can't have negative frequencies. I can't see something happen. It either happens or it doesn't, right? I can't have it negative happen, right? In terms of counting. This is the idea of cumulative frequencies, and I can set this up in Excel, but there's a way I can do this that I think hammers home the idea of what cumulative frequencies are, but also saves myself a little bit of time. So I could say, okay, the cumulative frequency, right, is the frequency of this bin plus every bin below it. There's only one bin below it. The next one, frequency of this bin plus every bin below it. So I'd have to type this out, right? Every bin is going to have one more bin before as I kind of move down the list. Well, I don't want to type this out a bunch of times. So there's got to be a way I can, especially if I have like 20 bins. So how can I maybe set this up? I only have to do it one time, then I can copy something down. So there's something going on with these cumulative frequencies. Think about it this way. So what's another way I could have gotten this cumulative frequency of 43? Well, it's the frequency of this bin, which was 5, plus every bin below it. Well, every bin below it would have just been the cumulative frequency of the bin below it. Well, what about this guy here? It's the frequency of the current bin, which is 3, plus every single bin below it. Or the frequency of every single bin below it would be the cumulative frequency of the previous bin, right? 43 plus 3. So what I'm really doing is looking at the previous bin's cumulative frequency, and then to get my new cumulative frequency, it's just take this cumulative frequency and add to it the frequency of that current bin that I'm looking at, or 3. When I set this up in Excel, this can save me a lot of time. Okay? Because if I type that type of a function in, where my cumulative frequency is just what was the cumulative frequency of the bin right before the one I'm looking at, plus that bin's frequency. Well, now when I copy this down, it should always, oops, here we go, use the cumulative frequency of the bin right before it, and then add whatever the frequency of the bin that we're looking at to it. Okay. And now, what should the cumulative frequency always be once I get to that highest bin? Total number of observations, right? Once I get to the highest bin, every single observation should have been counted somewhere prior, right? Another way to think about these cumulative frequencies, I'll type out some labels. I don't think I had originally, I didn't think to do this. And for some reason, I feel like it maybe helps. If it helps, let me know. If not, feel like, why'd you waste time? But the idea of a cumulative frequency is the first category is kind of easy. We're really saying like, sorry, is it less than, I mean, we should probably be careful. Like maybe I have the equalities on the upper, on the, maximum or not. But the idea is I'm saying, is it less than the maximum of this bin? Okay. Well, then once I get to my second bin, I'm counting for my cumulative frequency, the number of observations in this range, plus the number of observations in this range. So really, this cumulative frequency would say, if it's between 0 and 7,500 or 7,500 and 15,000, which is really the same thing as saying, is it less than 15,000? Right? Because if I add up these two ranges, that just covers everything from 0 to 15,000. And then I go down to my next bin. What its cumulative frequency is really saying is, well, how many observations were in this range, or in this range? Well, if it is in one of these three ranges, it has to be somewhere between 0 and 22,500, right? So your cumulative frequencies, right, when you're looking at these bins, it's really telling you how many observations are below the maximum of each of these bins. And once I get to that last bin, especially if I have a catch-all category, my cumulative frequency is really saying how many observations are less than, and we had a really large value in here, but we said theoretically it should be how many observations are less than infinity, which should be total number of all the observations. So it's another check. If you create these cumulative frequencies and you get to the last bin, and that number doesn't match up with the count function, you made a mistake somewhere in that cumulative frequency count. Okay. But I was just kind of creating these labels to give you a different way of thinking about these cumulative frequencies are telling you. Okay. Any questions on this? And you could do cumulative relative frequencies. It's the same idea. It's just that you're kind of getting like, instead of adding up the frequencies, you're adding up the relative frequencies. And you could do cumulative percent frequencies. Once again, instead of adding up the frequencies, you're adding up the percent frequencies. Right? You just be using a different column.
Could you show how to put in the graph one more time?
Yeah, so actually, I'll show you how to create a different graph. I'll show you both, right? But let's say I wanted to create my original histogram. And what the hell? This time I'm going to take the labels and I'm going to do my percent relative frequencies. It'd be the same way if I use my frequencies, I just select a different column. So the idea is I select my labels, hold control or hold command on a Mac, then select the column with what I want to graph. Now, usually that's just the frequencies. I'm just showing you a different column to show you that you can use a different column as well, which is your percent frequencies. Go to this column or bar chart. There it is, right? It quickly shows me the bulk of my data or the bulk of my universities have lower enrollments. And then there's kind of the rest of them are kind of evenly spread out in these other ranges, okay? Now I could have also, maybe, it's the only problem with zooming in. I have a very hard time moving images and things around. So what I could have also done is take my labels, hold control or hold command on the Mac, and I'm just going to select my cumulative frequencies. So generally the way we graph these, instead of using a bar graph, we use just like time series, we use this line graph, right? And I think I've gotten the slides, like, I don't know, the book, and I guess it's called an ogive. I don't even know where that name comes from. I'm sure it's Latin, but I've always heard it called a cumulative frequency polygon, bless you. And it basically shows you like, oh yeah, that first bin, you've got the majority, almost, just under 40 of the observations there. And then it slowly, right, kind of approaches that total number of observations of 50 by the time I get to my last bin. Okay. Just a different way of looking at kind of the distribution of the data. I don't always think this visualization is that helpful. I think more often than not, the histogram is probably a better visualization, but the cumulative frequency values can become useful. Right? Any questions before we keep moving? So I think there's a connect question kind of like this, but and let's kind of stress this point of cumulative. I'm going to just move this down here, maybe. Okay. Okay. So notice, let's say I didn't know what these frequencies were, right? So I'm going to keep scrolling over so we can no longer see the frequencies. Let's say I just showed you the cumulative frequencies. How could I back out the frequencies of each one of these bins? Well, for the first bin, I know the cumulative frequency is just the same as the frequency, right? But let's say I jump up to here. What's the frequency of this bin? Well, if the cumulative frequency is 49 and the previous bin's cumulative frequency is 47, what must be the frequency of this bin? It added 2, right? So even if you're just given cumulative frequencies, you can always, at least as long as you have all the cumulative frequencies, you can back out the frequency of each bin as well. Okay? All right, so this one would be what? Goes from 46 to 47, so 1, 43 to 46, so 3, 38 to 43, just 5, 49 to 50, which is 1, and then sure enough, oh yeah, those were the original frequencies that I got with the count history. Any other questions? All right, so I'm going to save this and I will post this later. And usually I'll start with, like, in this case, enrollments blank. That's what I'll put up before we go through it in class. Then I save it as whatever the name was, enrollment in class. So that's all the saved work we did in class. Okay. And actually, the one I think I'll end up posting, I'll also show you. You could have built a much, there's more bins here. There's a lot more data, but the same process, it would have taken just as much time to create these frequencies, for this huge data set as well. Because once you're using that count ifs and once you're using those shortcuts, it doesn't matter how big the data set is. It could be 50, could be 50,000. All right. It's going to take the same amount of time. Okay. Questions? All right. So we're getting a pretty quick crash course into Excel. I know it's a lot. I want you to start working once I get that Excel homework post, like I said, either later this evening or tomorrow, probably tomorrow morning. Feel free to come, into my office, reach out via email, like start working on it early. Don't save it right until the due date. I'll give you like a good 2 weeks to work on it too. And we've really went over all the material, but I know you've got kind of a concurrent connect assignment right now. And so I want to kind of make sure you have plenty of time to complete those, but I would highly suggest working on it early since we've covered really all the information that you would need, with a little bit of an exception, which is the next topic we'll get into. So part of the Excel assignment, you can start working on the histogram portion. There will be some parts where it asks you to calculate means, calculate variances. That's going to be what we're going to cover next. So I'll introduce that idea today, and we'll really dive deep into those numerical descriptive statistics on Wednesday. In fact, I'll put up another smart book that if you want to get on, just additional, you don't have to do it. It's worth 0 points, right? But if you want to do these kind of smart book assignments, I'm going to put up the next chapters after class today as well. Okay, chapter 3. So here, these slides kind of go along with all the work that we were doing. Talked about cumulative frequencies. We talked about different distributional shapes last week. So we're going to go all the way up here to think about how do we start to describe data sets with not these nice visuals, but just specific statistics. Right? And those statistics will tell us something about the data. So at first, what we're going to be interested in are measures of central tendency. So where, the data, if I looked at income data, some people make 15,000, some people make 135,000. It's all over the place, right? So where's kind of the middle part of that variable, or the middle part of that data set? That's central tendency. Where do we see most of the observations pop up? So we're going to have 3 different statistics that we calculate: the mean, the median, and the mode. So we'll talk a little bit about them today. I think we might get through all of them, but if we don't, we'll finish them up on Wednesday. And then we'll move to measures of variation, right? So I really talk more about the variance and standard deviation on Wednesday. But for now, what I want you to take out of this slide is that when we start talking about these different statistics, we're going to start using Greek letters to denote that this is the mean. So this Greek letter mu, this is the mean of a population data set, right? So that reflects that I calculated a mean, but it was from population data. X bar denotes that I calculated a mean, but that it came from sample data. So when we use this English lettering, that's going to be our sample statistics. Greek lettering, population statistics. That'd be a good thing to write down, right? So here, the median and the mode are a little bit different. I probably should have this on the slide. I kind of cheated here. It's one of the only exceptions where we don't use Greek lettering. So the median and the mode, I don't even think in the homework they denote the difference. Technically, the population should be M subscript D and N subscript O for the median mode. And for the sample, technically, you should just make it a lowercase m, right? It's one of the only exceptions where we don't use Greek lettering for the population. But I'm never going to try to trip you up on an exam or a homework assignment there. It's, M subscript D, N subscript 0. And the process is the same, no matter if it's population or sample data, which is not the case when we calculate variances and standard deviation. There, the process will look a little different, depending on if it's population or sample data. So for our measures of variation, sigma is the Greek letter that we'll use to notate the standard deviation. That represents a population standard deviation, or a standard deviation calculated from a population data set. S, the letter S from the English language, that will denote that we calculated standard deviation from sample data. And then sigma squared and S squared, population variance, sample variance. Okay. We'll talk a little bit more Wednesday, like, well, why are we just squaring it and calling it a new statistic? There's a reason why, right? We'll see kind of down the road, okay? So how do you calculate a mean? Here's a nice, crazy formula. I'll talk through it in a second. But if I were to give you 10 numbers, how would you find the mean of those 10 numbers? Yeah, to this point.
Add them up and divide by 10.
Yeah, right. You just add up the number of numbers that I give you and divide by however many numbers there were. Right. So if I got 10 numbers, add them up, divide by 10. That's all this formula is saying. So this summation sign, sigma here, right? Capital sigma. It's really just saying, okay, take whatever variable X you're looking at, start at the first observation. Whatever value is in for that variable, for that first observation, take that and add to it the next observation value for that variable X. Add to it the next observation value for that variable X. All the way up to capital N observation, which represents the number of observations in my population data, or start at the first, go to the very last observation, add all those values up, and then divide by the number of values I have, or divide by the number of observations in that population data set. Okay. So another way of writing it out, take the first observation value for X, add to it the second observations, the third, the fourth, all the way to the very last observation in that population data set. Once I've added those numbers up, how many numbers do I have? However many numbers are in that population data, capital N. Right? So capital N represents the number of observations in my population data. Okay. So that's mu, that's my population mean. Or we usually kind of in our everyday vernacular, my population average. Right? But over here will be more specific, it's a mean. The sample mean is the exact same thing. It's just that instead of going to the last observation in my population data set, we'll use lowercase n, which represents the number of observations in my sample data set. That's the only difference. Okay. So if I was wanting to find the mean birth weight in the US and I only had sample data, I just go through every observation, take the birth weights, add them all up, and then divide by the total number of births that I have in that data set, right? It's kind of like a two-step process. Add up all those values, then divide by the number of values I had. This is hopefully kind of review. It shouldn't be too tough. I think we'll work with this data set a lot throughout the semester, this birth data. So I think the average is like what, 3,200 grams. So if I have, one example here, just kind of a quick one. I've got some game, I don't know, it could be basketball, could be boggle. I've got the number of points scored. I've got 7 games. How would I find that population mean? Just gonna add up all these values, right? The 7 different observation values that I have. Divide by the number of numbers I've got, or the number of observations in my population data here, which is 7. Right? Add those values up, divide by 7, and I've got my mean. Okay. It's pretty, and it should be reviewable. So, usually I would use something like this for an eye clicker, but I'm not going to for today, just for the sake of time. And I also think, hopefully it's pretty easy to find means. But, I would show you something like this, show you a question that's very similar, different data. Now we're looking at commute times. I would then say, okay, which of these is going to be my mean commute time? Okay. All of these make sense. They're all somewhere in the middle of the ditch. What if I gave you like 15 as an option? Why can you rule out 15 as the mean right away? So remember, this whole conversation started with
The lowest value in commute time is 20, so you can never average 15.
yeah. So remember, the lowest value in my data set is 20. Remember, the mean, you started this out as a measure of central tendency. Where's the middle part of the data? How can the middle part of the data be below the lowest value? It doesn't even make sense, right? So, maybe I hit a button wrong on my calculator and I get some wildly large or wildly small value. But if I remember when I'm calculating, I won't get lost in the formula and I'll be like, oh, yeah, obviously it has to be somewhere between 20 and 90, right? Somewhere between my highest and my lowest value. That can prevent me from making a really dumb mistake, right? Or a calculator error. Okay. So here, right, I would just add up all my commute times. Got 7 different commuters. So divide by the total number of observations of 7. Okay. So what if, where are we at in time? I think we got like 10 minutes maybe. A little bit less. Okay, so what do I want to find my median and my mode? Right? To find the median, or I guess here I've got the mode and then the median, right? So the mode is very easy. I'm not going to spend a lot of time on this. I just go through my observations and I count up the number of times I see every response. Whichever response is the most frequent, that's the mode, right? So if I'm going through a data set, I see the most popular commute time here, 35 is the only one that happens more than once. My mode would be 35. It's the value that happens the highest number of times in this data set. Now, with a 7-person data set, it's not very interesting to calculate the mode. In fact, if I have a small data set like this, it's very possible that I don't have a mode, right? If every single observation value only happened one time, I wouldn't have a mode. But here, I think I actually did this because I'm going to use the same report here. No, I have medians here. Okay, I said I need a mode. That's probably why I went back. So go back here. you know, the mode for this data set would be 35, because it's the only one that happened. The median is going to be the value that exactly splits your data in half. Okay, so we'll go over in depth a little bit more about the process of calculating the median next class to start out. But the idea of the median is that it exactly splits my data in half, such that 50% of my observations are above that value, and 50% of my observations are below that value. Okay? So the median is a pretty nice measure of central tendency. I'll go through, like I said, a little bit more on the process, but I want to point something out about the median and the mode here real quick. Okay? So let's start with a very basic data set. Okay. What's the mean? Actually, I think do this. What's the mean of this data set? Well, I add these values up, and I would divide by 5. There's 5 numbers, so 30 divided by 5. This mean would be 6. Okay. But what if I think about a data set like that? So I don't know, we'll call this X, we'll call this Z. So the mean of X was 6. The mean of my second variable Z is going to be 1. If I add these up, I get 120 divided by 5. So if I'm doing math in my head correct here, it should be 24. I'll also sometimes do this off the top of my head. So if I ever make a mistake, let me know. But right, it has a significantly higher mean. But these two data sets aren't that different, right? It's just that this one had a huge outlier, right? And we're talking about the mean. One observation being really large or really small will greatly influence that mean, because every observation is treated exactly the same. They're all weighted equally. So one really high observation can pull that mean up a lot, especially in a small data set, right? Whereas if I'm thinking about we'll do the median here, and we'll do for Z and X. So the value that would exactly split this data set in half, well, if I choose the number 6, notice there are 2 observations above and 2 observations below. 50% of the data will be above or below that value of 6. Like I said, we'll go through a little bit more in detail the process of calculating the median to begin next class, but I just want to point something out. For this variable, what value would actually give me the median? Well, if I choose 6 here, I've got 50% of the observations above and below. I actually have the exact same median for these two data sets, right? And this median of 6 probably is a little bit more accurate, right? If I'm just going to see one of these values, well, 4 of them are below 10, and then I've got 100, right? So I don't think I should be thinking about the central point of this data is 24, because 4 of the 5, 80% of the observations are below the value of 10, right? So with small data sets, the median can sometimes be a lot more informative about where the central point of the data is, and it won't be skewed by these really, really high observations, okay? So we'll talk a little bit more about how we calculate the median, and I've already kind of alluded to it, but we'll then go back to saying, remember those right and left skewed distributions that we had? It wasn't because they had long left or right tails. It actually has something to do with the relationship of the median to the mean, okay? So we'll pick up on that next class on Wednesday. I'll get that first Excel homework posted up there on Canvas. Other than that, actually, sorry, before you head out, respond with your favorite letter for the day, and then I can go back to my office, make sure that every single person's iClicker was kind of working, match you guys up. So hopefully, if you haven't registered your iClicker, get on Canvas, register that physical version, or use the app. Respond with whatever letter is your favorite letter today. Everyone should be getting a 10 out of 10. Make sure you do that on your way. Okay? All right. We'll see you guys on Wednesday. I'll just leave it open as you leave. So.
Can we do it like later, or should we come to?
You'll have to do it now.
Oh, I had no idea. So if you didn't buy it, and you want to,
know you're here. Okay, so but send me, around so that if I got all these, I can name, give you points, because I know you're here.
Okay. Yeah, I'm in the same boat as him, I think. I tried to get it working, but okay, got my eye quickly.
Do you have any for
My eye quick?
No, the app.
Oh,
Yeah.
no.
Okay.
No, I have no clue.
I'm here what I told him. So you can just like download for a student, and it should pop up with my course that day.
Okay.
And once I open it up, you just respond, and I should be able to kind of collect it.
Okay,
You don't have it to register anything today.
okay.
Send me an email, make sure you have it registered for Wednesday.
Okay.
Tell that you were here.
I've got my physical.
Oh,
eye
okay.
clicker,
That's
but
probably gonna be easier, but
I-
if you have the app.
I haven't used it since freshman year.
Okay.
I'm a senior now and I opened it, there's no batteries in it.
Oh, okay, okay.
Times must have
Yeah,
been
just,
up.
just
someday.
show up. Show up Wednesday, send me an email though, and I'll
Okay.
manually go and add those.
Thank you, I appreciate it.
Oh, I always keep it on AA, just
Hey,
to make it easy, because that's what the defaults are, I just always leave on that. If teachers, the professors probably that like, different pain, and we're not, like, yeah, you get in other people and you can just like discard them right away, they should all just keep on AA. And then you can do pretty good. I don't use it, it's not going. I think if I remember right, hold this. There we go. Let's see. It should be good. Yeah, just leave it on that. I'll always use AA. You can just put it out, yeah, doesn't matter what you answer. Random, it just registers that you answered something. We'll get everybody credit for showing.
After I press it's.
Nope. Yeah, as long as you hit it and you see a little check mark. So you can change your answer after the fact too. So now I'm there.
All right.
Yep.
I just want to confirm that we've done correctly.
Yeah.
I've never
Oh,
paid
yeah.
before, so I got you, and then it
Yep.
wants me, I haven't paid before,
Oh, okay. So
That is
you would need,
correct.
yeah, you would need a subscription for, yeah,
that's
whatever.
what I wanted to make sure before I did it.
Yeah, yeah,
Okay.
yeah, yeah.
Right on,
And
thank
if you
you.
didn't get an answer in today, because you didn't have it, just send me an email and I'll manually edit it once I upload.
Sounds great, thank you.
Yep.